In the last question, we wondered, when a star collapses and spins faster, where does the extra energy come from? Let's begin with the law of conservation of angular momentum. You know that angular momentum is expressed as the product of moment of inertia and angular velocity. Here in this equation, L represents the angular momentum, I the moment of inertia, and omega represents the angular velocity. Angular momentum stays constant if no external torque acts. For a spherical object like a star, moment of inertia depends on its size. Moment of inertia for a spherical object is expressed as constant times mass of the object into the square of the radius of the sphere. Shape of the star is spherical. We'll consider spherical shape of a star. So the moment of inertia for a spherical object is represented as this equation. So it depends on two factors, mass of the object and the square of the radius of the sphere. So when the radius r shrinks during collapse, the moment of inertia decreases dramatically. And as you have already seen that angular momentum is the product of moment of inertia and the angular velocity. So it has direct relation with moment of inertia as well as angular velocity. So if the moment of inertia of an object decreases, the angular momentum will also decrease. In order to keep angular momentum constant, the angular velocity on the other side must increase significantly so that angular momentum remains constant. But here is the paradox. Rotational energy depends on both moment of inertia and angular velocity. The rotational kinetic energy is expressed as half times the moment of inertia multiplied by the square of the angular velocity. Therefore, as omega increases significantly, kinetic energy increases too. But where does this extra energy come from? The answer lies not in rotation, but in gravity. The gravitational potential energy is expressed as negative times the gravitational constant multiplied by the square of mass divided by the radius of the sphere. As the star collapses, its gravitational potential energy becomes more negative, meaning energy is being released. That released energy does not vanish. It transforms. It transforms into heat, radiation, and rotational energy. So the energy is not created. It was always there, hidden in the star structure, waiting to unfold. What looked like a paradox becomes a deeper harmony between conservation laws. To uncover more hidden truths of the universe, stay tuned to the Conscious Physicist. Till then, take care of yourself and keep learning.